And start again. Welcome, everybody, and welcome to the CIB Presidential Seminar Series that we broadcast from Purdue University. As you all are aware, the theme for this semester and the past semester has been Distinguished Women Researchers in the Built Environment. And again, today, we are very privileged to have Dr. Niluka Domingo with us today. Let me give you a brief introduction to her distinguished CV. Dr. Domingo is senior lecturer at the School of Built Environment at Massey University, that's in New Zealand, with a background encompassing both industry and academia. She is a leading researcher in sustainable construction with an extensive academic career. Dr. Domingo holds a PhD in construction management from Loughborough University, a BSc honors in quantity surveying, and she's a member of the New Zealand Institute of Quantity Surveying, MNZIQS as a short form. She also serves as one of the coordinators on CIB Task Group TG 124, that is on net zero carbon building design and construction, and is the current research lead at the School of Built Environment in Massey University. Dr. Niluka has been at the forefront of active research for the past 15 years, concentrating on key areas such as zero carbon initiatives, construction waste minimization, circular economy and practices, and sustainable construction methodologies. So please welcome Dr. Domingo. Niluka, over to you.
Yeah, I'm going to share my screen. Can you all?
And as Niluka start, please remember that it's 4:30 a.m. in New Zealand. So thank you again, Niluka, for an early morning seminar.
Can you see my shared screen?
Yes, we can.
Okay. Thank you very much, Mark, for the introduction, and welcome you all to my presentation on journey to net zero carbon in construction through life cycle excellence. Now, as you all know, we all are living in an era where uh, uh, urgency to address climate change has never been more pressing. So, construction sector as one of the major economies in the world is holding a key responsibility in achieving this target. So throughout my presentation, I'm going to navigate through the concept of life cycle excellence in achieving net zero carbon, because it is a continuous journey encompassing all phases in a building's life cycle, from design and construction to operation and decommissioning. So each phase has its own challenges and opportunities. So during the presentation, I'm going to present some of the initiatives taken in New Zealand, plus some findings from my research representing different stages in building life cycle. So without taking much time, let me first give you a bit of background where this has all started. So as you all know, there has been a lot of debates and discussions around the globe for many decades to control global warming and reducing greenhouse gas emissions to save the planet. As a result, in 2015, during COP21, around 196 countries signed the Paris Agreement, which stands as a landmark accord uniting 196 nations in a commitment to limit global warming below 2 degrees Celsius, and ideally below 1.5 degrees Celsius compared to pre-industrial levels by mid-century. So, ratified by almost all the nations around the world, this agreement symbolizes a collective resolve to address climate change. So, how this works is that the nations who sign the agreement agree to submit their nationally determined contributions, which we call in short NDCs, and those are where countries communicate actions that they would like to take to reduce greenhouse gas emissions in their particular country. So the agreement was to submit their nationally determined contributions by 2020, and then every 5-year cycles, these NDCs get reviewed and align with the goals of being carbon neutral by 2050. So that's the key kind of arrangement to keep up with this global warming and reducing harmful emissions from the environment. Now, with that, most of the countries came up with uh, different legislations, policies, and uh, uh, roadmaps and so on. So here you can see some of the countries that came up with climate change legislations aligned with their NDCs. Now, as you can see, in 2008, that was well before Paris Agreement was signed, UK introduced its Climate Response Act, and it was one of the first countries in the world that introduced a national level climate change act. However, after the Paris Agreement was signed, Sweden was one of the first countries to come up with the Climate Change Act, and followed by other countries like Netherlands, France, New Zealand, and Singapore. So, like I said, these countries have, based on their economies, based on their priorities, based on their emissions, they have different different goals, different timelines, different agendas. Uh, and For instance, some countries are a bit more ambitious in achieving this target, like Finland wants to be carbon neutral by 2035, and Sweden wants to be carbon neutral by 2045, while most of the countries want to achieve this by 2050. There are some countries like China who wants to be carbon neutral by 2060. So different countries have different agendas, but as a result of this Paris Agreement, most of the leading countries are committed and come up with their own legislations to make it happen. And in this context, construction industry has a major role to play. And according to the global statistics, around 21% of total emissions is coming from building and construction sector, which means building and construction sector is responsible for about 1/5 of total greenhouse gas emissions in the world. And there are two key emissions coming from building and construction activities. One is embodied emission, and the other one is operational emissions. So embodied emissions means emissions generated during the manufacture of the building products and the building materials used in new buildings, regular maintenance, and also end of life cycle. And operational emission is emissions produced by running the building. So those are the two key emissions in the building and construction sector. And now, at the recently concluded COP28, this report on global status report for building and construction sector was published, and it says that the sector remains off track to achieve decarbonization by 2050. So, according to the report, around 300 billion US dollars were invested in the building and construction sector to decarbonize it across the globe. However, according to the Global Building Climate Tracker, which was launched in 2020 to assess the progress in decarbonization of building activities, uh, the there's a gap between what needs to be achieved and what is achieved since 2015 to 2022. As you can see, the expectation of that expectation was to increase every year by 6 points according to the building tracker. So this building tracker has 7 indices, and based on those 7 indices, it reports the activities happening across the world on decarbonizing building and construction sector. So the requirement is to achieve increase 6 points every year, but interestingly, we are still at the same level where we started in 2015. So the report says that to keep up with the track, the initial requirement was increased 6 points every year, but now it's gone up to 10 points. However, if we couldn't keep up with the track, we might be off track forever. So this paints a very concerning picture for building and construction sector to get their acts together as soon as possible. Now, in terms of now, like I said at the beginning of my presentation, decarbonizing building sector cannot be achieved in one day, and it's not a responsibility of one party. It needs collaboration and coordination of the whole sector, in fact, whole nation as the end users of buildings. So to measure and keep track on carbon emissions in building and construction sector, number of different standards come up with different methodologies, but most common one is the European standard EN 15978. So this standard introduced different life cycle modules to calculate carbon throughout the building life cycle. Like I said, there are two main emissions coming from building and construction sector. One is embodied carbon and the other one is operational carbon. So you can see within this green boundary, the modules responsible for embodied carbon emissions in building life cycle. And operational carbon is usually during the operational stage in a building life cycle. To calculate the whole life carbon, you need to combine the two. That is covered in this blue borderline uh, here. So basically, from start to end of life cycle, you can see the modules which you need to account to when you are calculating the carbon emissions in a building. Uh, and there are three main stages. One is upfront carbon. So upfront carbon covers modules A1 to A5, covering product stage, transportation to site, and installation on site. And then during the use stage, uh, repair, renovation, and replacement of existing building materials, and then operational energy use, and then end of life cycle from module C1 to C4, deconstruction or decommissioning of the building, transportation, waste processing, and so on. And on top of that, this standard introduce beyond life cycle carbon emission or saving by reuse, recovery, and recycle of building materials. However, at the moment when we are reporting carbon emissions in buildings, it's not mandatory to report end of life cycle carbon emissions or carbon savings. But the European standard is now working to make it mandatory to report module D carbon emissions or carbon savings, because that gives the full picture of any building material, and that is key initiative to make material circularity happen in building and construction sector. Um, so and also there are some system boundaries introduced to report carbon calculations. So this is to standardize the process and help the people understand from where to where this carbon accounting happen in the life cycle. So for instance, here I have listed 5 key system boundaries. One is cradle to gate. Cradle to gate is basically the product manufacturing stage carbon emissions, and cradle to site is product manufacturing plus delivery to site, and cradle to end of construction is product manufacturing plus up to installation on site, and cradle to grave covers product manufacturing till end of life cycle of the building, and cradle to cradle covers full life cycle including module D. So those are the key system boundaries in carbon reporting, so that once you know the system boundaries, you know from where to where the carbon is captured in a building life cycle, and you can report carbon based on these different levels in a building life cycle. And according to research, this uh, if you want to reduce specially embodied carbon emissions, you have more opportunities in the early stage of the building. So as you can see here, if uh, the opportunities or the potential to reduce embodied carbon significantly drops after design is finalized. So actions needs to be taken early stage in a building life cycle to reduce embodied carbon emissions. However, this is applicable to operational carbon emissions to a certain extent, because to reduce the operational carbon emission, design has a key role to play. Like for instance, making passive design and using uh, uh, fittings, I mean, light fittings with less energy consumption and so on. So design and early stage in a building life cycle has a key role to play in reducing emissions in the whole building life cycle. And here I have mapped some of the key carbon reduction practices that use in different life cycle stages. However, I'm not going to explain one by one because you probably know most of these practices. Uh, and I'm going to, from here onwards, I'm going to present some of the initiatives taken in New Zealand, and also some of the findings from my research representing different life cycle stages on carbon reduction. So, like I said in the beginning of the presentation, that uh, early design stages, early phases in the building life cycle has more potential to reduce carbon emissions. Now, in order to understand the carbon emissions from a building, we need to know what are the materials that goes into a building and what is their contribution to total emissions. So, to understand this, we did some case studies here in New Zealand uh, for building sector. Now, here you can see the findings from a residential case study that we did. So what we did was uh, uh, we assess one typical residential project, detached home with 4 bedrooms, and the floor area is roughly about 200 square meters, two-story building with 2.5 bathrooms, and then we assume some, and based on the bills of quantities and actual materials order on site, and also making some assumptions on material replacement cycles, we calculate the total material mass that goes into a building over the life cycle. And also based on that, and using some available carbon databases, we calculate the embodied energy of these materials. So you can see here the top the key materials that contribute to carbon emissions in residential projects, and about 50% of the carbon is coming from concrete and steel products in residential projects, and timber and plasterboard also contribute significantly. So about 80% of total embodied carbon in residential project is coming from concrete, steel, aluminium, timber, and plasterboard. So these are the key materials. Based on this case study, that we identified top 5 materials that contribute to embodied carbon. The other material is around 17%. Um, and I guess this is kind of representing the embodied carbon emission in a typical residential project in New Zealand. And we did the same study taking a non-residential building, and this is office building with mainly reinforced structure with some structural steel elements as well, 6-story building. And in this case study, we came up that again concrete and steel are the key uh, emitters, including aluminium. The rest is not very significant. So as you can see from these two case studies, concrete and steel are the two main culprits in carbon emissions in the building industry. So in New Zealand, some initiatives has been taken to reduce carbon emissions on these two material manufacturing process. For instance, uh, because this is not only the case in New Zealand, concrete is one of the most extensively used construction material across the globe, and according to uh, according to statistics, about 14 billion cubic meter of concrete manufacture in the world annually. And out of that, in terms of emissions, 90% of concrete emissions is coming from cement manufacturing. So it says that conventional cement manufacturing emits like 4.2 billion tons of carbon dioxide, and which is like 8% of total emissions in the world. So in New Zealand, recently they launched a roadmap to achieve net zero carbon in the construction industry. So one of the key initiatives that they are taking is to replace the cement with supplementary cementitious materials. And you can see some of the alternative materials identified in New Zealand, and the government believe that by substituting cement, it will be the industry will be able to achieve or reduce carbon footprint of concrete by 20 to 80%. So, however, there are some barriers associated with this, and like high initial cost and lack of local supply of SCMs, and high cost to import SCMs to New Zealand because New Zealand is a remote country, and of course reluctance to use anything is difficult to use in the first place. And also this has some performance issues, like they say that if we replace cement with something else to make concrete, it takes longer time to get to the required strength compared to traditional cement. So those are some of the key barriers that limit the use of these SCMs in construction. If we look at statistics, this is somewhat common in EU, UK countries. About 25% use SCMs in their concrete production. However, in other countries, the percentage is quite low. For instance, in US, it's about 5%, and Australia 3%. New Zealand is still like 2%. So it's not very common in practice at the moment. However, it's one of the key initiatives New Zealand is taking to reduce decarbonization in the concrete industry. And the other culprit, like I said, is steel. And steel, actually, there are not much that uh, government can do. However, in short term, they are planning to go with some initiatives like optimize steel framing, for instance, thinning the structural steel beams where unnecessary, and also trying to recover and reuse steel as much as possible. At the moment, the recovery rate of steel is around 75% in New Zealand. So, trying to increase the recovery rates. And recently, the government launched a project with New Zealand Steel. This about $300 million investment to replace the steel manufacturing process with electric arc furnace. By doing that, they plan to remove two kilns out of four at the moment, and replace one melter. Currently has two melters, and this method allows external scrap to use in the process. So by doing that, they believe around 45% of steel manufacturing emissions could be reduced in the future. So fingers crossed on that. So basically, in the pre-design stage, the key things that we can do is to select the right materials, go with low carbon alternatives, and uh, design the building to optimize or reduce the embodied carbon emissions throughout the life cycle by identifying what are the key kind of materials that contribute to carbon emissions in the life cycle. So, moving on to on-site carbon reduction, we have done a survey with 100 contractors in New Zealand representing different tiers, about one third in each tier. So, we identified five key carbon on-site carbon reduction practices used by New Zealand contractors, and you can see the weighted averages here as well. So basically, they are trying to reduce carbon reduction by making material transportation and handling more effective, like acquiring locally sourced materials, and using renewable sources to transport materials, and also reduce transport frequency by utilizing larger or full truckloads. And also during the material selection and usage, try to use innovative and low carbon materials, and implement on-site waste management plans. It's not mandatory yet in New Zealand. And also promoting more use of more recycled materials. Uh, Plus use EV vehicles to run on site and things like that. Also, they are considering to practice to reduce on site carbon reduction. And there are some challenges that we identified too, like high initial investments, lack of skills, and project based nature of carbon reduction, because at the moment it's not compulsory. Nothing is compulsory. So all these carbon reduction practices are based on uh, project requirements, what client needs and what the team needs. So it's not compulsory, and which make contractors very difficult to standardize their practice. So that is one of the reasons why these practices are not very common in New Zealand industry. And we did another study to try to identify waste management in New Zealand, because managing waste is one of the ways that embodied can reduce embodied carbon emissions during construction phase. So we surveyed, like we assess waste reports from around 100 residential projects across the country to understand the waste generation rate and what are the key materials that goes into waste streams. So as you can see here, a typical New Zealand house generate around 28 to 38 kilograms per square meter. This is not compared to world statistics, this is not very low or very high, this is in the medium range. However, the waste diversion rate is still 75%, and the rest goes to landfills still in New Zealand, which is quite high. And in a typical New Zealand house, about 8 to 10 kilograms per square meter goes to landfills. And again, by doing that, we try to understand what are the key materials that ended up in landfills and how we can recover them to reduce embodied emissions from building construction. Uh, and moving on to operational stage, in operational stage, embodied emissions are coming from material replacement, refurbishment, and so on. But the key emission during the operational phase is due to building use, the energy used for building operation purposes. So, according to the energy report published recently in New Zealand, New Zealand use around 550 petajoules of concrete across all sectors, and out of that, residential and commercial sector consume about 1/4 of the total energy use in the country. So that is quite significant amount, and the government is planning to shift from uh, non-renewable sources to renewable sources in energy production. So at the moment, around 30% of New Zealand total energy consumption is coming from renewable sources, and the government is planning to reach 100% renewable electricity generation by 2030. So that's the current target. And again, these are some findings from some of the studies we did to understand the energy behavior in New Zealand homes. So, according to some research, especially done by Green Building Council in New Zealand, it says that the buildings are not performing to the required level of their home star or green star rating, and one of the reasons is the behavior of occupants in the operational stage. So again, according to statistics, average household use like 10,000 kilowatt hours of energy annually. And so we did this study to understand the energy behavior in New Zealand homes using immigrant population, because a lot of immigrants are coming to New Zealand, and we try to understand how they behave, because they come with different practice, different countries with especially Asians. So according to this study, they prefer temperature uh, in their room around, majority prefer 22 to 24 degrees Celsius, which is quite high compared to a typical Kiwi requirement. And the living areas and bedrooms are the key areas that they want to heat during the winter times. And if and we did a survey to figure out what are the appliances that use most energy in a typical New Zealand house, and uh, space heating is like 1/3 of the total energy use in average New Zealand house. And the reason why this is high is most of the New Zealand homes do not have central heating or fixed devices to heat the space. And not they don't even have double glazing. Double glazing became mandatory since 2010. So the building stock that built up before that doesn't even have double glazing. So during the winter time, the indoor temperature can be really cold within the houses, and without having any fixed device to heat the space, most of these homes are based on some small appliances which consume more energy than having a central or fixed unit. So so the government introduced a healthy home standard in 2021. The requirement in this standard is for all, especially the rental homes, there has to be a fixed heating device capable of maintaining minimum 18 degrees Celsius during the winter time. So by doing that, and this will come to effect from mid 2025, so by doing that, the government is trying to reduce the energy use for space heating within New Zealand homes. Um, and moving to the last part of the building life cycle, end of life cycle, one of the key things that construction industry could do is circularity of materials. Now, in most countries, circularity of materials is not very common. It's still a new concept. So we still use traditional take, make, waste approach. But in circular economy, waste is going back to the cycle as a resource. So we did a study in New Zealand, try to figure out what are the options available to recover, reuse these materials, come as waste during construction and also from the deconstruction of buildings. So the key materials that get separated at waste processing plants are hard fill, timber, plasterboard, and steel. Uh, some waste processing plants process plastic as well. However, due to small market scale, recycling potential is not fully explored for plastics at the moment. Hard fill is like almost half of the total waste uh, coming from buildings, and that includes concrete blocks, tiles, stones, and so on. And most of the time, what they do is they grind these materials to a suitable sizes and use for backfilling and roading kind of projects. And timber, there are two types of timber waste: treated timber and untreated timber. Untreated timber they process into garden mulch, and treated timber process to use as wood chips for fuel and those purposes. Plasterboard normally go through a grinding process and then separate paper and gypsum in the plasterboard, and then paper sent for recycling, and gypsum most of the time ended up as a fertilizer in the agriculture industry. And uh, steel and metal products again goes to recycling. And like I said, uh, again, circularity of materials is not something that you can consider at the end of the life cycle. There are some preconditions that needs to be made. So we did a systematic review to understand what are the prerequisites to enable circularity in construction, and also what are the barriers. So you can see 8 key prerequisites and obstacles to uh, to initiate those prerequisites in the building life cycle. Um, and yeah, so that is end of my presentation, and I would like to conclude my presentation with a famous quote from Simon Wiesenthal, that our actions today will shape the world of tomorrow. because like I said throughout the presentation, achieving net zero carbon in building and construction sector is not something we can do overnight. And by embracing and being open-minded to new technologies, sustainable materials, and efficient processes, we have the power to transform our industry. So, moving forward, it is important that we remain committed to collaboration, work transparently, and open to continuous improvement. And that by working together across disciplines and sectors, share knowledge and best practices, we can accelerate this goal to be carbon zero by uh, carbon zero in building and construction sector. So that's the end of my presentation, and thank you very much. Any questions?
Niluka, that was very interesting. I mean, what is happening around the world? You made a very good presentation in summarizing, the greenhouse gas emission and decarbonization efforts. Let me open the floor for questions. Please open your mic and ask question if you have. I cannot see all of you, so it'll be difficult for me. But if you have a question, please open your mic and ask a question. All right. So while people are thinking, let me start with a question on or that I was thinking about. You mentioned earlier in your presentation that about 1/5 of the total greenhouse gas emission is due to construction, and both embodied and operational aspects of it. And you covered extensively about the embodied GHG emissions. But what are your thoughts on the operational side? How can we what is being done and what do you think needs to be done to control some of that?
Yeah, I mean, this 20% includes both embodied and operational emissions, because I think if we take the whole building life cycle, according to my knowledge, product manufacturing stage is contributing a lot to both embodied and operational emissions, and during the operation also that there are a lot of operational emissions coming from building and construction sector. So during the operational stage, I mean, to reduce operational carbon, like I said, moving to renewable energy sources is one way of reducing uh, operational carbon emissions, and the other one is like changing the mindset of the users. So like I said, in New Zealand, some research findings shows that there are some buildings in New Zealand that uh, goes beyond the uh, normal requirement, normal code level. So if a building is built to the existing code, it only can achieve up to 3 or 4 home star or green star rating. But there are some builders and some clients want their building to perform well, so they actually put more effort to achieve 6 star, 7 star, and more. However, the research shows that during the operational stage, they are not performing to the required level. So that is mainly because of the behavior of people in the building. So I think some kind of mindset change and using some sort of training or education is a way to reduce these operational carbon emissions in buildings.
You. Any questions from our audience? Please open your mic and ask question. I cannot see everybody on my screen, so I'll have to rely on you to just open your mic.
Hello.
Hello.
Yes,
Hi.
Ashutosh, go ahead.
Yeah. So I had a question. So, what do you think, like, to reduce the carbon emission, like Operation Carbon? What do you think New Zealand, what can one learn from New Zealand? So, like, the rest of the world can learn from New Zealand. Like, one special thing that New Zealand does to reduce the carbon emissions. What would you feel? What would that be?
Uh, okay, regarding operational emissions, uh, one of the key initiatives New Zealand is taking is to move from renewable sources to non-renewable sources to renewable sources, like I said. So actually there's not much that I can say about construction. However, I'll give an example from the transportation industry. So for instance, New Zealand is actually the previous government. We don't know what kind of initiatives this government will take, but they uh, the previous government gave a lot of incentives to promote EV vehicle use in New Zealand. For instance, they gave very attractive rebates and canceled the whole road user tax. However, it is back again with the new government, so we don't know where this new government will head in terms of carbon reduction. So that is one of the key initiatives they have taken to reduce these emissions. I mean, energy related emissions, and when we talk to some contractors, actually in the past they were thinking of completely changing their fleet into EV vehicles because there are so many incentives around. So those are some of the things that New Zealand have taken to reduce um uh, operational carbon emissions, but not related to construction sector.
Mm-hmm.
But like I said, they are trying to reduce the energy use in the houses by uh, installing, like I said, fixed heating devices, which is also not very I mean, I can't say it's not very common, but there's considerable number of houses in New Zealand without any heating device, without any double glazing, and so on. So they are working to improve the building code, building the requirements, and also try to promote some of these initiatives. Especially Green Building Council is working towards that.
Thank you.
You, Ashutosh?
Yeah.
Any other questions?
I have a question.
Sorry.
Oh,
Yes, go ahead. Let's do Aluatobi and then Bimal.
okay. Thank you so much, Professor. Thank you so much for the presentation. It was really amazing. So just a follow-up question from Ashita's question would be, knowing fully well that construction industry is a little bit peculiar in the sense that it's not just the contractor that would really love to like implement some of this sustainable design and materials. Sometimes it's dependent on the client and their willingness to adopt this in their buildings or projects. So my question would be, do you see anything with regards to like policy making that could help? For example, if there's this policy set in place that says, okay, 20% of your construction materials should be sustainable materials, or 30% should be accounted for in design and all of that. Like, what are some policies that you think can help the adoption of sustainable designs and materials and further improve reduce carbon emission in the construction industry? Thank you.
Yeah, thank you. That's a very good question. Actually, at the moment, there are no mandatory policies for the construction industry to use sustainable materials or use low carbon materials. And uh, however, like I said, now at the moment, when we talk about waste management, at the moment in New Zealand, uh, there's no on-site waste sorting, or it's not mandatory to have site waste management plans. But the government is now working to make site waste management plans compulsory in the consenting process. So it is still not in the process. However, the work is happening. So very soon there will be some initiatives in terms of waste reduction. However, at the moment in New Zealand, there are no incentives or mandatory policies to have to reduce emissions from building and construction activities.
Thank you.
Yeah.
To be. Bimali, did you have a question, so we can
Yes,
go to you
Mark.
and then Ted and then Peter Paul.
Thank you, Mark. Hi, Dr. Niluka. It's a nice presentation, very informative. Thank you very much. So my question is regarding the circular economy. You mentioned that circular economy is could be a solution for this to reduce carbon emissions in construction industry. So what is like the current status of circular economy using in the construction industry? Do you have any idea? And what are the initiatives that they can use regarding circular economy, circularity to reduce net zero, like carbon emissions to achieve net zero emissions?
Yeah, circular economy is something that uh, the building sector can consider at the end of the life cycle. But like I said, it can't start at the end of the life cycle. The things needs to be done throughout the life cycle to make it happen. For instance, it needs to there has to be information transferring from the start to end. In New Zealand, still circular economy practice is at very, very, very initial stages. In my presentation, I presented some of the ways that these key materials can be reused and recycled at the end of the life cycle, but that's not 100%. So there should be a lot of work done, and there should be platforms to transfer these information throughout the life cycle to make it happen. And there are some challenges because for instance, once you build a building, then it will go to facilities managers and end users, and then goes to demolition contractors at the end of the life cycle. So there needs to be some communication and coordination that needs to be done throughout to get this circular economy up to speed. However, it's still in the very, very, very initial stages here in New Zealand and most of the countries as well. I
All
hope
right.
that answer your question.
Yeah, and what do you think about the role of circular economy to achieve net zero emissions? Is it like a good solution or?
Well, end of the life cycle, if we don't recover those materials, then that will end up in landfills. So which means we need new materials to build our new building stock. So by trying to circular these materials, we can kind of reduce some emissions, especially embodied emissions and also operational emissions by producing these materials in the life cycle. So it is one of the solutions available at the end of life cycle stage, if possible.
Yeah, thank you, Dr. Niluka. Great explanation.
Bimali? Ted, over to you.
Thank you for the presentation. I was interested in the high number of residences that don't have double glazing. Has there been any research done to identify the cost-benefit analysis, but not necessarily cost, but the carbon benefit analysis of converting those houses from their single glazing to double glazing or something even more efficient?
There has been some work, but it's not on top of my head. But there are some research going on to figure out the cost-benefit analysis of refurbishing or retrofitting these existing building stock to meet the new standard. But unfortunately, I don't have the figures or numbers on top of my head. And in New Zealand, it is still not like I said, it is it's getting mandatory to have fixed heating device for every home by 2025. However, it's not compulsory to make all the windows double glazing or something at the moment. So it's not, since it is not compulsory, only people who wants to change the glazing does it. Otherwise, it's not happening at the moment. Does that answer your question, Ted?
Yes, thank you.
Thank you, Rosa Weidner. Peter Paul, over to you.
So thank you for the presentation. Really good overview of what's happening in New Zealand. I wondered if, well, building codes, changing building codes takes a long time, of course, but I wondered if there is also in New Zealand already uptake from more voluntary accreditation schemes like Lean or BREEAM or EDGE.
Yeah, we have New Zealand Green Building Council with Home Star and Green Star ratings.
And is this, yeah, and is that already, well, applied in sufficient amount? Or
Well, it's not compulsory. It's not compulsory, but if any builder or any client wants their building to assess and give a rating, they can approach Green Building Council and then they work through. But it's not compulsory to get a rating for every house in New Zealand, every house or every building in New Zealand.
Now, another question was, in the Netherlands, we see quite a large interest in, well, shifting to timber and biomass products for building. You show that concrete and steel are clearly the large contributors. Yeah. You see the same, well, policy maybe or interest in New Zealand to shift to timber?
Yeah, actually, there's some research going on to see whether timber structures can replace steel structures when doing high-rise buildings. So there's some work going on in New Zealand to test that potential. And most of the New Zealand homes are timber framed anyway. Yeah. So this is for, yeah.
Thank you.
Thank you, Peter Paul. Well, we still have time for a few questions if you have a burning question. Anybody? All right. Well, let me ask my question then. So, Niluka, you pointed out that now in the decarbonization index, the efforts are not as was planned, and now to recover, looks like there needs to be a 10-point increase every year. Now, what are some of the efforts, if we still need to meet the 2050 goal, what are some of the efforts that you're aware of that are being taken or should be taken to achieve that objective?
Yeah, actually, this index is mainly looking into carbon dioxide emissions from buildings, and then energy intensity and use of renewable energy sources. So things like that, actions taken, and so there are a couple of others which I can't remember now. So I mean, investing more on those things are the way to go if we want to increase these decarbonization efforts in the building industry, for instance, moving on to renewable energy sources and incentivizing the use and reduce the energy intensity in buildings. So things like that. Yeah.
Thank you. Questions from the audience? So let me continue that discussion as a follow-up question. You mentioned that the 5 different system boundaries, particularly cradle to gate, cradle to site, cradle to construction or end of construction, and then cradle to grave, and then cradle to cradle. Now, in terms of achieving the objectives of decarbonization, which of these is there like a priority order that you're aware of, that where we need to be focusing more or less to sort of speed up the efforts?
I think cradle to site is one of the key areas, because product manufacturing stage, especially concrete and steel and also aluminium, create a lot of emissions, uh, starting from the product manufacturing stage itself. So that is one area I believe that needs to work on, like trying to introduce more low carbon or low carbon materials, alternative innovative materials, to replace these main culprits. And the other option could be in the operational stage, so it's not covered in one of the system boundaries, but I mean by because it has more potential to reduce energy during the operational stage by changing our behavior and through education and so on. So I believe those are the two key. On top of that, through government initiatives, we might be able to reduce carbon emissions during construction as well. So cradle to end of construction has a lot of potential by changing the design and also use some good practices on site. But end of life cycle, really not much potential other than circular economy and those aspects. So I believe it's the early stages mainly that could help.
Thank you. Questions again, open to the audience? Any follow-up questions from the audience? Okay, well, let me ask my last question then. And very good presentation, Niluka. A lot of questions I have, but let me ask one more in interest of time. So, you in one of your slides or during your presentation, you mentioned that steel has embodied carbon, 32% embodied carbon versus 20% for concrete, whereas in terms of material mass, concrete was much more, I think 45% versus just 3% for steel. And then I noticed in one of your later slides that the amount of steel going to landfill seems to be very low compared to some of the other materials that you had mentioned. Then on top of that, if steel were to be recovered, there's also energy consumption in that recovery process. So,
Yes.
what is your thought in terms of recycling, and you mentioned circular economy. What is the most optimal steps to be taken in all of these contexts that I just mentioned?
Well, I think the most optimal solution is to go with low carbon alternative. Like for instance, like I said, now concrete, there are some research going on to replace with SCMs for cement. But for steel, like I said to the previous question, can go with, if we can go with some timber frames instead of steel frames, that can potentially reduce a lot of carbon in especially in high rise buildings. So I mean overall, going with low carbon materials is one of the key to reduce emissions, I guess.
Well, thank you very much. And there was another question that can we get a recording of this session? So yes, all of these recordings are available through CIB website. And not only Niluka's presentation, but all the previous presentations are on the CIB website. So Vimali, to your question, please look it up on the website there. If you don't find it, let us know, and we'll be glad to share it with you as well. But having said that, thank you all. Thank you, particularly Niluka, early in the morning. What a fantastic seminar. Thank you again for taking time. And a lot of questions are coming up, and I'm sure people would be very much interested in looking up the recording if they miss this seminar. And at the same time, thanks to all of you in the audience for making this presentation or attending this presentation. So let's give Niluka a big round of applause. Please open your mics and give her a big round of applause. Thank you very much.
Thank you very much, Mark, for the opportunity.
So I'll see you all next week with yet another distinguished speaker. So thank you all again. And again, Niluka, thank you very much.
Thank you, Mark. And thanks for joining others. See you. Bye.
See you all. Bye.